So good morning, everyone. First, let me just say thank you to Dan and the conference organizers for inviting me. This is incredible. What's even more incredible is that this is free, right? So the price is right. My name is Tariq King, and I'm the head of quality at Ultimate Software, which is based out of Western Florida. And you know, in the previous talk, there's a lot of truths there, right? One of the reasons that I can be here at Codecamp is because I've invested in my peers. I've invested in the people that report to me so that they can run stuff. So I increase my bus factor, right? And I'm off time. Just letting you guys know straight up. I was in Tokyo last week. I'm here today. I don't know which time zone I'm in because I came from the United States and I just never got off of Tokyo time. But let's get started. So I've given this keynote in the original version a number of places last year at HUSTEF, the Hungarian Software Testing Forum, at PNSQC, different places in the United States. And it's normally an hour talk. But I created this Codecamp edition assuming that I would have 30 minutes, but now I have like 20 minutes. So we'll see. So there's definitely no room for questions. Don't even try that with me. But let's get started, all right? Let me turn this off. A comfort zone? Yeah, I'm always comfortable while I'm on stage. Let's just thank the conference sponsors, the partners. Let's give them a round of applause. There's a lot that goes into organizing a conference and paying for it. And so again, it's just amazing that this is free. I've never seen anything like this. And a big part of that is community, and we'll talk about that. All right, so this talk, artificial intelligence and its ability to probably terminate testing as we know it, or manual testing. I actually hate this term manual testing, but the truth is that testing is very focused on being very manual. And we'll talk about that. So what is testing? You ask a room like this what testing is, everyone has a different opinion, and that's because software testing has a lot of different parts to it. And at the core of it, we're checking facts about the program, making sure that certain things hold. But there's a lot of work that goes into that. There's a lot of experimentation, evaluation, learning, modeling. All of these things are parts of testing. And when we sit down and think about automation as we know it today, it's also very manual. Because what are we automating? Like someone has to sit down and still encode a test script, whether it be Selenium or JUnit, TestNG, but they're still manually doing that. And as they're doing that, they have to do a lot of pre-work. You have to still create the test cases, design them, and so on and so forth. And so even automation, as we call it, the only thing that's automated is the execution and maybe generation of the results, because when the tests fail, you still have to manually go and look at why it happened and then fix it. And so this myth that we have of automation is truly that. You see, as far back as the 1950s, there was this idea of lights-out manufacturing, where their idea of automation was such that we could have the machines running and we could turn the lights off. But our philosophy when it comes to testing is far from being a lights-out philosophy, right? And so I'm going to tell you a story, and I'm going to tell it in the reverse order. In other words, it's game over already. Imagine that artificial intelligence and machine learning have already terminated testing as we know it. And the reason for that is because if this is our world, then this is software. And guess what? Software is eating our world. And that's already done. Like, we have passed that phase. But if this is software, then this is artificial intelligence and machine learning. And AI and machine learning are going to eat software. And when they're done eating software, guess what? All eyes on us. And so artificial intelligence, it's really this ability of the machines to imitate or mimic intelligent human behavior, this broad category. And Hollywood typically paints AI as a very scary thing. We're thinking about the end of humanity as we know it, right? The Terminator. And part of this talk is purposefully dramatic, and even the title, Can It Terminate Manual Testing? But AI doesn't have to be scary, right? In fact, we use AI to do a lot of fun things, and we're going to walk through some of the history and some of the milestones. But we started around playing games, right? And it's still playing games today. So back in 96 to 97, you had IBM's Deep Blue defeating world chess champion Garry Kasparov. And so how did it do that? How did it manage to beat Kasparov? Well, the answer is pretty simple. It was really less about some of the advances that we see today and more about brute force computing and the branch of AI that deals with game trees. In other words, what we're talking about here, and if you take a simple example like tic-tac-toe, is just an enumeration of all of the different states throughout the game and all of the different moves that you can make at each state, and so we can build that tree. And then you can start to figure out, well, in a given state, what is the best move that I can make to help me get towards that outcome of winning the game? Of course, chess is no simple game tree, right? At each level, you have about these 20 possibilities, and that starts to explode. But Deep Blue had dedicated chess hardware, and it went to as many as 8 up to 20 levels deep in starting to figure out and compute and use that game tree to figure out the best move. And so that was really more about brute force computing. In 2010, IBM's Watson, and guess what we were doing with Watson? We were still playing games, right? Now the games leveled up. Natural language processing, Jeopardy. I mean, I like to watch Jeopardy. I always feel kind of stupid when I watch Jeopardy because, like, you know, you get like one out of like a streak of 20 questions that happen there, and it's like, man, these people are smart, right? But yet, Watson was able to beat 2 of the best Jeopardy players, right? One with the longest streak and the one with the highest score. And so we continue to see these advances in artificial intelligence. And now you see Watson all over the place. And AI is being used in almost every domain you could think about: manufacturing, retail, medical, and it continues to grow. Then bring us to 2016. We had a very significant breakthrough where we had Lee Sedol, who is one of the best Go players in the world. And the difference here when it comes to Go, which is an ancient Chinese game, is that brute force computing no longer was sufficient to kind of beat Go. And so, why is that? If we take a look at comparing chess, chess has 16 pieces in the start state, 6 different types of pieces, and each moves differently. You have 35 possible moves per state, 80 moves per game, and the whole objective is to capture the opponent's king. Now, the rules of Go are actually simpler, right? There's 0 pieces in the start state, 1 piece type, and they all behave uniformly. But the key here is that there's actually more than 250 possible moves per state, 150 moves per game, and the goal is to capture the most territory on the board. And so, when you do the numbers in terms of state space, the number of possible games that can be played, you have about 10 to the 120 when it comes to chess versus 10 to the 761. So that's more than the amount of atoms in the universe. And so it's actually physically not possible to tackle this problem with brute force. Actually just don't have enough space on the machine. And so the key there was something called deep learning. And actually it was deep reinforcement learning. But the idea was that we were now able to kind of teach the machines to be a little more human-like. And now we're using things like deep reinforcement learning to drive cars. Problems that people said were just impossible to be solved using a machine and all those things are now being solved. I remember when it was voice recognition that was the thing that couldn't be solved. And now we're able to drive cars. And the key here is that at first, the machines suck at whatever the task is, but then they get better. And so the key to that is understanding what is machine learning. And this is really about the programming model, right? We typically look at how we get the machines to actually act without being explicitly programmed. And one of the best ways for me to describe this is using one of my daughters. I have two now, so I know exactly what he was talking about. We were thinking about three, but that curve, I don't know if I want to go back on that curve. But this is my 5-year-old daughter, Soraya. And if we compare Soraya to a machine in terms of how she acts or learns to act, you see a couple differences. You see, machines typically are programmed to follow very specific instructions. Soraya does not like to follow instructions. Soraya learns a lot by experience. And so, in this photo shoot, of course, there wasn't a robot there. That's me. We were in the park and taking these pictures, and I just told her, let's play peekaboo, right? And she jumps behind a tree. And I think back, well, how did she learn that? And how did she learn most of the things that she learns? It's usually by just seeing examples. And that's what machine learning is all about. And so learning from experience as opposed to these explicit instructions. And so what does it mean for a machine to have an experience? Well, the answer is really about the data. You see, we can represent experiences as data. We can give this machine some examples of raindrops. And then we can also give it examples of things that may not be raindrops. And when it encounters something new, it can say with some degree of certainty, well, you know what? I think this is a raindrop. And it does that type of classification. And it may not get it right the first time, but the whole idea here is that it gets feedback and it can get better over time. And that's called classification. And the cool thing about machine learning is that you actually didn't need to know that domain concept of raindrop or not raindrop. These could have been just blanket categories, X and Y, and it could have just said, you know what, these things here are separate from these other things because they have these features, and these features are not present over here. And that's more of a clustering problem. And so there's several different types of machine learning, but the whole idea is that if a program can improve based on previous experience or previous data, then we can say it has learned. And in terms of some of the categories, we just mentioned a little bit about supervised learning. Like if we label the data up front and we had knowledge of the outcome, then we could train the machine. And that's really about learning based on known patterns. Unsupervised learning, you don't have labels on the data, so those categories are these blanket categories. There's no knowledge of the outcome, but that is really good for discovering unknown patterns. And the machine is teaching us these new patterns, right? Oh, I didn't know that these things are similar. And then there's reinforcement learning, which is kind of like this quasi-state. So you generate data through actions, and then you reward or punish it after. Like after it wins the game, now you know that those were good moves, right? And so you're training it after the fact. And so that's really about learning by trial and error. And it's incredible because the model that we have of the human brain is still the most impressive computational model today. And actually this idea of artificial neural networks is very loosely based on our own biology, very, very loosely. But the idea here is that you have inputs and you have outputs. And then there's this like magic box in the middle, right? And as you go through, you initialize that box randomly and you feed your inputs, you get some outputs, and then you have some evaluation. And it might be terrible at first, as I mentioned. And if it's terrible at first, what you can usually do is that you can take the difference between the loss, you can feed it back since we're using like weights in here to distribute this stuff, and you can compute how much loss you had by going backwards, and then you can come back forward and try to reduce the loss by playing with those weights. And that's how it improves. All right, so Act 2. It's about powering up. The whole idea of this talk is how can we use things like artificial intelligence and machine learning to actually power up testing. Because you see, our current techniques don't give us very much. But maybe AI can be the thing that helps us to overcome some of the grand software testing challenges. And so, testing. I mean, testing is this thing that sometimes we overlook at the real challenges that are there. But testing is about choosing and selecting a finite set of tests from this infinite domain. And we're going to go all the way back to 1975 with some of the earliest testing theories. Because testing is just about treating the program as a function initially. You feed some input to that function, and you get output. Nothing too hard. And so a test is really about selecting from that domain and making sure that it maps correctly to the range. And so you take some input D, and that produces f of D, and then what you ask yourself is the f of D an acceptable result? In other words, is D okay or is it not okay? Well, that sort of looks familiar, right? That looks very similar to this thing, this machine learning that we were doing, and it's incredible because actually, like machine learning, for the first time, we have something that's actually trying to simulate human judgment, and that's what testing is doing. We have this judgment that we're basing the software, is it correct or is it not correct? And machine learning maps directly to that, right? And so when we run tests, we usually try to select from that domain a subset, and then we check to see that all the outputs are okay. And so for all t, if t is successful, if and only if, for all t in that test set, you have okay t. But then what's crazy is that what we try to do next. We try to use that test, and for that test to be ideal, like the whole idealistic model would be that we would run that test, and if that test passes, that somehow that means that every single input and every single output in that domain is also correct. Like, that's crazy. Like, you're trying to find a needle in a haystack, and you're trying to reason about the correctness of this global program. And so we usually have this huge challenge, and it all boils down to coverage. Like, there's always a gap in coverage, whether that be a gap in the input space or covering the output space, and that leads to this whole idea of state space explosion. And we're trying to do all that and deliver the software. And this guy right here, that's the tester. Like, if I was him, I would want some help. Wouldn't you want some help? And that's what artificial intelligence is trying to do. It's trying to help us, or we can leverage it, or that's my hope, and one of my goals is to try to leverage it to help us. In other words, we want to be able to look at how we do testing. As we add features to software, the complexity grows exponentially. But we actually add tests today using conventional methods in a linear fashion. And so there's this huge gap in coverage. And maybe AI-driven testing is something that can help us to cut into that gap. And so it's all about the age of the robots. And one of the reasons that we start to talk the way we have with it being done is because we're actually doing it. Like, these are two examples of systems that are using AI to do functional testing. One on the web and one on mobile. There's an internal tool built at Ultimate Software, and this is a commercial tool by a startup called Test.ai. And these bots are exploring the software, they're making mistakes just like humans would, and they're correcting those mistakes, and they're learning about the application and reasoning, building models. And so there's a lot involved here. Right now it looks like magic, but usually any sufficiently advanced technology starts to look like magic. And so the bots are here. And at a high level, the way that this works is that we use machine learning techniques. We combine that with test drivers and interaction frameworks and different tools that help to exercise the system under test. And we leverage that at scale, right? Deep learning, cloud computing, and so on and so forth. And there's a lot of benefits to that. You see, the first thing is that AI-driven testing is very general purpose. Like, we're able to apply it. That function, that machine learning function, that whole diagram can be applied to almost any type of problem you could think about. And so that holds for testing. Any application or domain. Once you train it, it just knows how to do it for others, or it can get feedback and get better at those. It's also what we like to call pesticide-free in testing, where it's not just running the same test over and over and getting those same results, right? That's called the pesticide paradox in testing. It's generating new tests each and every time. And then, like we said, it's very scalable. So now the first act. The first act that needs to happen is that we need to get ready. Because artificial intelligence and machine learning are right here. And actually, they're not in a box. They're actually outside of this box. And we have to do our part to make sure that we can help with this whole AI revolution. Because as Hollywood would portray it, something bad can really happen. Like it's not just Hollywood. Like some bad things can actually happen if we don't get a grasp on technology and any sufficiently advanced technology. And so you have to start to think about what happens when this stuff starts to fail, especially with the ways that we're using it in these days. And so this is a real fear, right? And we see software failing and causing catastrophic failures. And it's just one of those things where we say, well, we have to get a grasp on software quality. And with AI, it's even more important. You see, our traditional model of programming is to take inputs, you write a program, and you produce outputs, right? Pretty straightforward. With AI, you start with your inputs and your outputs. And the magic is that function. And every time you train that machine, you actually modify that function. And it's doing that after it's been released. What would we do if we changed the program? We would test it before we re-release it into the wild. And so these systems actually need to have some sort of testing built into the design and the runtime of the system because they're adaptive. Every time you train that model, it's a new function. So now you need to build testing in, and this is where a lot of my research for my graduate school was held on building runtime testing into adaptive systems. Because see, if we have systems that can self-configure, self-heal, do all this self stuff, they need to have self-testing as an implicit characteristic. And we need bots that are on the inside testing this adaptation. And so we started here talking about AI-driven testing and using AI potentially to give us gains when it comes to software testing. But it can't stand alone. Like implicitly leveraging artificial intelligence to do anything means that we need to start thinking about how to test AI systems. And because these systems are adaptive, we need to start thinking about designing systems to be self-testable. And I mean, this is excellent because one of the things that we did about 2 years ago was to start to form a community around artificial intelligence for software testing, where AI for testing really has to do with those three main areas, right? And I come here and I see what is an amazing community. Like this is, I've been all over the world and I've never seen something like this before. So this is definitely something that's very special because the reason that we formed the association is because we felt the only way that we can solve these challenges with AI is through a community because the problem is just too large for one person, one company, one effort to solve. Only through collective intelligence can we start solving some of these problems and by people coming together. And so Jason Arbin and myself, Jason is the CEO of Test.ai, we formed ASTA, which is the Artificial Intelligence for Software Testing Association at aitesting.org. Now about over 1,000 people have joined the community. Hopefully I get 1,000 more. This would be awesome, right? But it's all about community. And so with this keynote, this is just scratches the surface of opening your mind to this problem. If you want to really see how this stuff works, because again, I showed you a lot of magic, right? But how do you know I'm telling the truth? You shouldn't trust me. You should always find out for yourself. Show me how it works. And so I'm going to do that a little later today through this talk, Test Machina, Demystifying AI-Driven Test Automation. Because what I found was a lot of people were wondering how this stuff works, and there was all these startups popping up, and people really couldn't figure out exactly how it works, and I'm going to show you that. And so now we've reached the end. I've made it, but this end is really not the end. It's really just a beginning for us to start solving these problems. Thank you.